Hi everyone, thank you very much for being here. What I would like to do tonight is tell you a little bit of a story in the next 10 minutes or so. And it's a story that started about 6 or 7 years ago when I was in the middle of my university degree. And at that time I used to be quite a diligent student, and I was spending most of my time at the library or in the lab. And then, as in the most predictable movie ever, I fell in love. And I fell in love with this guy, and it was amazing. He treated me super nicely, and he kept telling me that I was the most beautiful and stunning woman he had ever seen in his life. And everything was perfect. Then, one day, he sat me down and he told me these words: Martina, we need to talk. Now, we all know what that means, right? For sure, it ain't good news, especially when they use your full name, so remember that. But anyways, instead of, I was already ready for the drama to go down, but instead of breaking up with me, he told me that he had a genetic condition that was affecting his vision. And that's how I learned that, while to me, our friends, our family, and the world in general that used to look something like this, well, he was seeing the very same scenario in a completely different manner. Now, on the one side, I finally understood why he thought I was so pretty. And on the other side, this got me more and more interested in his condition and in general in conditions that involve vision loss. And I learned that in the world, there are more than 250 million people that suffer from visual disabilities and blindness. And there are many, many different types of conditions. Some are genetic, others are environmental, and others are trauma-induced. And these are just some examples for you to have an idea of how different people can see the world that's around them. But what most of these conditions have in common is that they involve damage and degeneration of a very specific organ of our body that is called the retina. Now, the retina is located at the back of the eye, as illustrated here, and under normal circumstances, the cells of the retina are quite healthy and happy. And just in case you're wondering, I did draw this myself. It was not the work of a child. When we have a disease or suffer a trauma, the situation is a little bit different. So what happens? The cells of the retina starts feeling unhappy, unhealthy, they start dying off, and you can imagine this whole situation as if the entire tissue started screaming for help. Now, what is the solution to this? Well, in my mind, the solution was quite simple. Regenerate, just replace the old damaged cells with new functional ones, and that's it, problem solved. And actually, this is what a lot of animals can do. Now, just to be clear, this is not an animal. This is a picture of my younger brother when he was about 5 or 6 years old. And even if here he looks like an angel, at that time when we were little, he was everything but angelic. And yes, please look, not an evil look here. And he didn't make my infancy particularly easy or smooth. And I distinctly remember one day coming back from school, we went to play in the garden, and he found a lizard, and it occurred to him that it would be the most brilliant idea in the world to just grab the lizard by the tail and start shaking it off as hard as he could. Now, I don't know why he did that, and I'm not sure what happened after, because I ran away screaming, but the end result was that the lizard lost its tail, pretty much as in this picture here. Now, I don't know if any of you ever attempted something like this, but if you did, well, you would have learned that lizards are able to regrow their tails. Like, they can get a brand new tails without any kind of problems at all. And this regenerative process looks more or less like this. The video doesn't play. Can you play the video, please? Yeah? Great, like this. So this is an example of limb regeneration, but more or less the principle is the same. And it's quite impressive, isn't it? Now, and similarly, you can almost completely destroy the retina of these animals, and within a few weeks, they will be back to perfectly seeing again. And this applies not only to lizards, but to many, many other organisms, such as these guys here. But unfortunately, we cannot do any of this. So just to be clear, please do not try this at home, because I don't take responsibility for any of that. Now, in this direction, what we need to do, and what I do as part of my everyday life, is trying to find an alternative solution. In particular, the approach that I use is called stem cell therapy. And the easiest way to explain it is that I put stem cells here in the middle of the eye, and you can think of these cells as helper cells, which means that they have the ability to help fellow friends that are in trouble. Now, how does it work? When the retina is healthy, not much happens, and the helper cells just stay there. However, when we have a damage or a disease, the helper cells are able to hear, to perceive the screams of their friends, and what they do is that they go there where needed and help them out. Now, in my language, The screams that the retina gives off are called factors or signals, while the ears that allow my helper cells to perceive such screams are called receptors. Now, since we're talking about stem cells, I thought it would be a good idea to tell you a little bit about stem cells and why we think they could potentially represent the medicine of the future. Stem cells have two main characteristics. So on the one side, they are self-renewing cells, which means that they keep dividing, generating many exact copies of themselves. On the other hand, they have what is called multipluripotency, which means that they have the ability to become or differentiate into any type of specialized cell that is found in your body. Or in more colloquial terms, they're just immature baby cells. They haven't decided what they're gonna do with their life just yet. So stem cell research gained momentum and flourished after the isolation of the first world human embryonic stem cells in the 1990s. And since then, we have learned a lot about stem cells, and we learned that there are a lot of different types of stem cells. And actually, the use of embryonic stem cells comes with a lot of moral and ethical concerns, because imagine they need to be derived from a human embryo that is about 5 days old. So what we decided to do is to turn to the investigation of other types of stem cells that are called odal stem cells and are found in the odal body, such as in the brain, bone marrow, skin, or skeletal muscle, and in many other organs. And yes, there are stem cells in the adult human body. They are just extremely rare. They're very, very difficult to find. And we've spent years trying to optimize protocols and procedures that would allow us to isolate in the future. And that future is now. Now we can do that. So we wondered, what is the least controversial source of stem cell that you can think of? Any ideas? Guesses? Well, I'll tell you. The answer is adipose tissue, or fat. And for sure in our society that's available, there's plenty of that. So this got me thinking, does it mean that in the hopefully not so distant future, if I had a problem with my vision or with whatever, any organ of my body for what matters, I could walk into a clinic, undergo a minimally invasive procedure, and come out with my vision or tissue functionality restored and having lost a couple of kilos? I don't know about you, but I'll take the deal. I'm quite happy with that. And actually, I'm sure you wouldn't have to go through too much trouble to find some altruistic donor willing to sacrifice a little bit of their belly fat for you. Try to do that with bone marrow donation, see how that goes. But anyways, back to the point. So we realized that fat, or more precisely liposuction fluids, are an excellent source of a particular type of stem cells that are called mesenchyma stem cells. So we can isolate them, put them in our eye with a receptor that will be able to interact with signals coming from the retina and help them out. How do they do that? They do that in one of two ways. So on the one side, they can rescue dying retinal cells by providing everything that they need in order to get better and survive. And on the other side, being stem cells, they can replace the cells that have already died and become functional retinal cell types themselves. Now, so far so good, no? But the real situation is a little bit more complicated. Because if this was the whole story, there would be no blind people in the world today, and I would not have a job. So let me ask you a question. If you heard this, which is not playing right now, so I don't know why, it always happens when we try, it works, and then, no? Of course. Yeah. Great. Would you know what to do? Anyone? Would you know what to do? Would you? Well, the answer is no, and it's not a surprise, because I guess you do not speak Japanese. But what if you had a translating device? What if you had a device that could translate that for you? What if you heard was this? Well, in this context, it still doesn't work very well, does it? But don't worry, it's not you. I've been living in Barcelona for a few years, and I still do not understand Catalans very well. But let's try again. What if you heard this? Or this?
Help me, my friend!
Then you would know what to do, wouldn't you? So what I'm trying to tell you here is that when you have a damage, there can be many, many different types of signals that you can imagine as screams in different languages. Now, in order for the therapy to work, our cells need to have the correct type of translating device or receptors, which means that, let's say, a Catalan receptor will not be able to respond to a Japanese signal and vice versa. What is the problem then? Well, the problem is that most of the cells that we transplant either do not have any translating device or they have the wrong one, and either way they are unable to respond to the signals coming from the retina. So in this direction, what my job really is all about is trying to understand what are the different types of languages of the screens, the different signals that the retina gives off, and with this knowledge I can design a strategy to provide my little helper friends here and also here for you in real life with all the types of different receptors that it needs in order to optimally respond to the signal coming from the retina, reach the site of damage where it's needed, and prevent the retinal cells from dying. And of course, all of this is in the hope that in the near future we will be able to help the 253 million people that around the world suffer from visual disabilities and blindness as a result of retinal disease and degeneration, even if for some of us it would mean stop being so beautiful. Thank you very much.